our definition of improper integral from the previous video, that the integral from a to infinity of f of x dx, we're defining that to be the limit as r goes to infinity of the integral from a to r of f of x dx. And so we did one example in the previous video. Let's do a couple more examples. Let's do the integral from 2 to infinity of 1 over x cubed dx. So we just know from before that we're going to rewrite this as a limit. Let's use r as the letter. We can use any letter we want, but might as well use r. 1 over x cubed is, of course, x to the minus 3. And so this is what we have to evaluate. Antiderivative of x to the minus 3 is x to the minus 2, and we divide that by minus 2. We plug in 2 and r, and what did I forget to copy there? Downside of Sharpie, so it would be difficult maybe for me to squeeze that in, but let me squeeze in that limit there. Okay, I'll make sure I copy the limit here. If we don't write that limit, it's not good notation. We need to include that limit. Okay, so when we plug in r, we get minus 1/2 times r to the minus 2. And when we plug in 2, we get 2 to the minus 2, so 1/4. So this is where we're at. So let's see what's going on here. That is just 1/8. And as r goes to infinity, 1 over r squared, that goes to 0. So this whole thing goes to 0. And so our answer is just 0 plus 1/8 is 1/8. So here's what we evaluate this improper integral to be. And because this is finite, we conclude that yes, it does converge. Okay, so that's a positive example where we see that something does converge. Let's see an example where something is going to diverge. And also we're going to have our first example where instead of going off to infinity on the upper bound, we have one where the lower bound is negative infinity. So how do we do this? Again, using the definition here of improper integral, we're defining it to be this limit as r goes to minus infinity. Replace that minus infinity with r. So r to our upper bound is minus 1 over x dx. And so the integral of integral of 1 over x is going to be, let me not forget that limit either, natural log of absolute value of x. It's going to be really important for us to remember the absolute value, because here the values that we're plugging in are going to be negative values of x, and we can't take the natural log of negative values of x. We can only take natural log of positive values of x, so we need that absolute value sign in there. Okay, what do we have? The limit as r goes to infinity. We need to keep copying that limit of natural log of absolute value of minus 1 minus the natural log absolute value of r. Okay, so what is going on here? Well, natural log of absolute value of minus 1, that's just natural log of 1, so that's 0. And then oops, I made a mistake here. I miscopied that minus sign, I didn't copy that minus sign. So that should be a minus, that should be a minus, and that should be a minus. As r goes to minus infinity, absolute value r goes to positive infinity. And so natural log of positive infinity, that's going off to positive infinity itself, comes with that minus sign. So this limit goes to minus infinity, and so because it's not finite, we conclude that yes, this limit does diverge. So one example where this converges, one example where this diverges. So let's have a pre-class problem, first pre-class problem. So here's an integral. Determine if this is convergent or divergent. If it's convergent, evaluate it. Give me an actual number answer. If it's convergent, like that 1/8 was an actual number answer.